To contrast with the Sealy Vulcan coil, I have here the Campbell E portable Tesla coil. And this small high frequency coil is just the size of a suitcase, and it only consumes 5 amps at full power. But it's still a great portable Tesla coil. It was used for minor X-ray use, and it was also used for therapeutic use. There are outputs for diagnostic lamps and cautery knives, even an eye electromagnet in the middle of the case. And there were also thermofaradic outputs, which was a sort of early form of diathermy. This was the first coil really in competition with Mr. Kinraid on the market. They started off with a slightly earlier version of this machine in 1901, and they continued to sell thousands and thousands of machines into the 1920s and 30s. And later they developed Coolidge sets and more modern X-rays. But the company started off 2 brothers. The main inventor was Charles Campbell, and we heard a great story about Charles that I guess sometime in the 50s or 60s he was of advanced years, maybe mid to late 80s, and a company was still using one of his X-ray machines, and it went out of order for some reason. And as the company no longer existed, he personally went to the company and restored the machine back in the functioning order for the hospital. So we love to hear stories like that. It's really neat. This machine is sort of one of the origins of that company, and it has a single pancake coil and a socket to hold an X-ray tube stand over here. You have outputs, the Arsenval, which was a tapped winding of the pancake coil, thermofaradic, which was more or less just the primary coil itself. There are sinusoidal outputs here, which are tapped from the main transformer. And you have lower voltage cautery and diagnostic lamp outputs. There's also a regulator for the lower voltage sides. You have a frequency switch on this side. For X-ray use, it was always set to the lowest frequency. For high frequency and violet ray type treatments, you could increase the frequency, and that would diminish the spark length and make the sparks a little more practical for therapy. To demonstrate it first, though, we'll show low power with the lowest frequency setting. Now there's a single thin heat sink silver spark gap about 3/4 inches in diameter. Now, to show as an example, I'll increase the frequency several settings so that you can see what the therapeutic outputs of this machine would be. This is the next highest frequency. This is higher still. And this is the absolute highest frequency. This is typically something that would have been used for violet ray treatments. Now back to the lowest frequency setting, I'll demonstrate the arcs that were typically used for powering X-ray tubes. Now the electrodes could also be removed, the lid could be closed, and make a very compact machine to be carried around. It was typically used as a therapeutic machine. If a physician could take it to someone's home, for example, or if someone broke a leg or an arm and they needed an x-ray and couldn't make it to the doctors, they could throw it in the back of their carriage or horse and buggy or whatever they had at that time and take it to someone's house. And because it only used 5 amps, you could plug it into even residential homes had typically like a 10 amp circuit, was about the maximum at that time. So there's no fear of overloading the house circuit at someone's house, and you could still make a practical x-ray if you had to in an emergency. And the therapeutic aspects were also incorporated into this machine. The engineering inside this is pretty amazing. There's not an inch of free space anywhere. The transformer is one of the most complicated out there. Each tapped reactance, the reactance coil is actually built into the transformer, where you have individual tapped coils for each level of primary power, and then you have your isolated secondary coil for the high voltage, which produces about 2,000 volts in this machine. And then you have individual coils still for the sinusoidal and for the diagnostic and cautery circuits. So the transformer was a beast in itself. Then you had these very elaborate positive stop ceramic switches below, which were made and patented also by Campbell. You have the spark gap, which, although it's silver and it's prone to overheating after a while, the heat sinks did draw away the heat, so it was an early form of air-cooled spark gap. And the pancake coil on the side was very efficient for its size. I mean, it does produce a flaming arc at only 5 amps. The coil was insulated in beeswax and rosin. In the earlier model of the machine, they also had interchangeable high-frequency coils that you could put, if you wanted to do therapy. In the Model D coil, which was the one sold prior to this, you could simply take out the high-frequency coil and replace it with a coil with fewer turns of wire. They could have been used for more like diathermy treatments. In this particular machine, it's all incorporated into one. Sometimes it makes problems when there's machines like this, because if you were heavily using the diathermy or D'Arsenval or thermal-faradic outputs in this machine, the high-frequency coil would still be active. So if you had to do a prolonged treatment, you'd be putting a lot of stress on the high-frequency coil. And especially having all the windings in one pancake coil, if you consume a lot of power from the low-voltage side of the machine, you tend to promote arc-overs and short circuits in the high-voltage circuit. Though, fortunately, most of these machines are all still functional. I've seen one of them, the first one I got, was burned out, and it was a complete nightmare to rewind the thing. But I suppose the physicians knew of the warnings of how to use coils and how to be careful with them, not to use certain, not to drain the coils in a certain way to promote the insulation on them. Very nice coil, portable set, 1902.